Good morning. In this video, I would like to explain about addition law and multiplication law of probability.
Now let us see the statement of addition law of probability. If A and B are any two events and are not disjoint, then we have to show that P of A union B is equals to P of A plus P of B minus P of A intersection B. So in order to prove this statement, just to take the diagram, Venn diagram. So now let us see here. We are having with the sample space S and we have the two events A and B. So before the videos we discussed about the sample space means the set of all possible outcomes, we call it as a sample space. So in this the elements of A and B, so this element we are going to represent it as A intersection B bar. It means the elements are not in the set of B. So this is what you call it as A intersection B bar, and this is what we call it as A bar intersection B. It means the element which is not in the set A, and we know this is the common elements which are having A intersection B. So now let us see here, in order to prove this statement, let A and B are any two disjoint sets. Let A and B are any two disjoint sets. So it means that they cannot both occur same times. They cannot both occur at the same time. That is what we call it as disjoint sets. So now we are going to define P of A union B is equals to P of A plus P of B minus P of A intersection B. So now let us see here where A and A bar intersection B. A and A bar intersection B. These are disjoint. So here A dash A bar both are same. So now let us see here A and A dash are two disjoint sets. These are two disjoint sets. If these are two disjoint sets, how you are going to write here now? This is equals to P of A union B is equals to, I am going to write this as P of A union of A bar intersection B. P of A union of A bar intersection B. So we know the theorem as, if these are disjoint sets, we are going to write this as P of A plus P of A bar intersection B. So now let us see here, whenever we are having the two elements, common elements, it means the element not in the set A, the elements in the set B. So from this Venn diagram, we are going to write the element of P of B. P of B. How you are going to write P of B? This is the common element of P of A intersection B and union of. So what are the elements we are having on the right hand side of the set? Here we are having A bar intersection B. So these are the two elements in the set. Now we are going to write this as P of B is equals to P of A intersection B plus P of A bar intersection B. So now we are going to write it as P of A bar intersection B is equals to P of B minus P of A intersection B. So this is what we are going to do it as P of A bar intersection B. So now let us see here, from this, if you call it as equation 1, from this equation 1 we are going to write it as, now we just substitute this from equation 1, we are going to write it as P of A union B is equals to P of A plus the element in the place of P of A bar intersection B, we proved that this is equals to P of B minus P of A bar intersection B. So now let us see here, so this is of A intersection B. So now we are going to define it as P of A union B is equals to P of A plus P of B minus P of A intersection B. This is an addition law of probability. Now let us see the theorem on the three events of A, B and C. For any three non-mutually exclusive events A, B and C, we have to show that P of A union B union C is equals to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. So before the theorem of the two events, we already know how to solve the problem on addition law, two events. Now we are going to solve it is on three events. Now let us see the proof. We are going to write this as P of A union B union C. This is what you are going to write it as, P of A union of B union C. So again, when you are assuming this as the second event of B, we already studied before the theorem A union B. What is P of A union B? P of A plus P of B. Now in the place of B as, we are going to write it as B union C. We are going to write it as again the addition of theorem for two events. So how you are going to write for this as P of A plus P of B. It means in the place of B union C, we are going to write it as P of B. P of A plus P of B minus P of A intersection of B union C. So now again, see, for this step we are going to write it as P of A. We know the addition of probability for here is A union B. We are going to write it as the way A plus B of B minus P of A intersection B. We are going to write B union C as P of B plus P of C minus P of B intersection C. This is what we are doing the second as P of B union C. We are writing it as the second term as the addition of two events of P of A union B, like that. So now let us see the third term. What is third term? Minus P of A intersection of B union C. We know the distributive laws of the theorems. So based on that, we are going to write this as P of A intersection B union P of A intersection B union A intersection C. Now let us see again, this is our having the two elements A and B. So now how you are going to write this? P of A plus P of B plus P of C minus P of B intersection C. Again this is in the form of A union B. So what is A union B? P of A union B is equals to P of A. See, minus you are taking it as a common term. P of A union B is P of A plus P of B minus P of A intersection B intersection C. So here minus is a common term. So now we are going to write this as P of A plus P of B plus P of C minus P of B intersection C. Multiply minus here with each term, you will get minus P of A intersection B minus P of A intersection C minus of minus plus P of A intersection B intersection C. So in this theorem we are going to represent, remember, only the two events of addition of probability. If you are familiar with that, then we can solve the three events on the theorem of A union B union C. Now let us see the problem on addition law of probability. A box contains 30 chocolates numbered from 1 to 30. One chocolate is selected at random. Find the probability that the number of the selected chocolate is a multiple of 5 or 6. So before that, we saw the theorem of addition law of probability, that is what? P of A union B is equals to P of A plus P of B minus P of A intersection B. So here we are having the chocolate, the number of the selected is a multiple of 5 or 6. So in order to do this solution, I am taking, let A be the number of a multiple of the element of a 5 and B be the number of the elements is a multiple of 6. So now the thing is, we are going to finding out the favorable elements to get favorable elements. So the favorable elements of what? We are going to take it as a multiple of 5. Favorable elements of multiple of 5. Multiple of 5. So this is of actually we are having how many chocolates numbered? The numbers from 1 to 30. So we are writing the multiples of 30. So it will be 5, 10, 15, 20, 25, 30. So now for this, if you are going to write the probability as probability of happening of an event A is equals to the favorable cases are 6, and we are going to define it as P of E is equals to favorable number of cases by total number of cases. So P of E is equals to, we are going to write it as 6 by 30. So now in the same way, we are going to write it as the favorable elements of multiple of 6. The favorable elements of multiple of 6. So we are going to write the multiples of 6. 6 2s are 12, 6 3s are 18, 6 4s are 24, 6 5s are 30. So here we are having again P of B is equals to, we are having the favorable elements as 30. Now the thing is, in the given question, They're asking to finding out the number of the selected chocolate is a multiple of 5 or 6. So or means we are going to define it as a condition of A union B. So we are going to apply it as the addition law as P of A union B is equals to P of A plus P of B minus P of A intersection B. So when we are going to observing these two events A and B, if the term is repeated. So now let us see here, the element A 30 is there and the element B of the favorable case is also 30. So the element 30 is repeated here. 30 is repeated. So now whenever we are going to define it as a P of A intersection B is equals to the element common in the multiple of 5 and in the multiple of 6 is 1. So it will be what? 1 by 30. So now we are going to apply an addition law of probability, that is P of A is equals to 6 by 30 plus 5 by 30 minus 1 by 30. So taking an LCM, so we will get this is equals to 30, we are getting it as 10, so the probability is equals to 1 by 3. Now let us see the multiplication law of probability. For any two events A and B, so we are going to show it as P of A intersection B is equals to P of A into P of B given A when the element P of A is greater than 0. And P of B into P of A given B when the element P of B is greater than 0. So here in the before video we already learned about the conditional probability. Whenever we are having the conditional probability, suppose we are going to define it as a P of A given B is equals to the conditional probability of an element of A. When the event A is said to be conditional probability, it means the event B is already happened. So in that, how you are going to write it as P of A given B is equals to P of A intersection B by P of B. It means that which the element P of B is already happened. Whatever the element we are writing in the denominator, the event which is already happened, and that element we are going to write in the denominator, so that we are going to define it as P of B greater than 0. In the same way, if an event B is said to be conditional probability, if an event B is said to be conditional probability, it means that the event A is already happened. So we are going to write this as P of B given A is equals to P of A intersection B by which event is already happened here? P of A is already happened. So we are going to write this is equals to P of A greater than 0. The same thing of the conditional probability we are going to define in the multiplication law of probability. Now let us see the problem on multiplication law of probability, that is if P of A is 1 by 3, P of B is 1 by 4 and P of A union B is equals to 1 by 2. Then we are going to finding out P of B given A and P of A given B bar. So before that in the multiplication law of probability, we already observed that P of B given A means the conditional probability of event B, which means the event A is already happened, and we are going to know the formula. Apply the formula as P of B given A is P of A intersection B by P of A. It means the event A is already happened. So now in order to prove this, the first thing we know that P of A union B is equals to, the addition law is P of A plus P of B minus P of A intersection B. But here we already know the value of A union B. We are going to finding out the value of A intersection B. So what is A intersection B here? This is equals to P of A plus P of B minus P of A union B. Now let us substitute the elements. P of A is 1 by 3 plus 1 by 4 minus 1 by 12. So here the LCM is equals to 12. So 4 plus 3 minus 1, the element is equals to 1 by 12. So now what is our first question? The first question is P of B given A. So now what is the formula for P of B given A is equals to P of A intersection B by P of A. So what is the value of P of A intersection B? This is equals to 1 by 12, and the value of P of A. What is the value of P of A here? P of A is equals to 1 by 3. So 1 by 12 into 1 by 3. So the reciprocal it becomes numerator becomes denominator. So that it will be equals to 1 by 12 into 3 by 1. So this is equals to what? The value is equals to 1 by 4. Now let us see the second question. What is second question? P of A given B bar. So this is equals to P of A intersection B bar by the event is already happened, that is P of B bar is already happened. In order to do the second one, the first thing we are going to finding it as P of B complement is equals to 1 minus P of B. So what is 1 minus P of B? 1 minus 1 by 4 is equals to 3 by 4. So now let us see that we are going to finding it as A intersection B complement. A intersection B complement. What is the formula for this? This is equals to P of A minus P of A intersection B. The elements in the set A, not in the set B. This is equals to A minus A intersection B. So now what is P of A here? 1 by 3 minus P of A intersection B. This is equals to already 1 by 12. So this is equals to, we got it as 1 by 4. Now substitute in the second question. What is second question? This is equals to P of A given B complement is equals to P of A intersection B complement by the value of P of B complement. So what is A intersection B complement? This is equals to, we already got the value as 1 by 4 and P of B complement is the value of 3 by 4. So now what is the value? 1 by 4 into 3 by 4, this is equals to 1 by 3 is the solution of this for this problem.
Thank you.